guys, let us look at another example on finding the area. In this case, we are not just finding the area of a triangle, but we want to find the area of a parallelogram ABCD. So guys, in this parallelogram, we have the measure of two sides. One of the sides measures 5 and the other one 7, and we have the included angle as well. Now guys, one has to know some basic facts and basic things related to a parallelogram. Some of the things about the parallelogram that we kind of have to know is that the opposite sides are the same and the opposite angles are also the same. So guys, there's one quick thing that we can do here to kind of make it easier for us to find the area of this parallelogram. Guys, how about if I draw this diagonal between D and B? So if I draw this diagonal between D and B, what's going to happen? Now we have actually created two triangles that are basically congruent to each other, because we know this side is equal to this side is equal to this side, this is the common side, and this angle is equal to this side, and now from there we can see that they are congruent triangles. So what does that mean? That means if I find the area of the one of the triangles, then I just have to multiply it by 2 to get the area of the whole parallelogram. And in fact guys, there's a nice formula which tells us how to find what is the area of a parallelogram. So area of a parallelogram is just the product of the two sides times the sine of the included angle. Why? Because we know the area of a triangle is 1/2 of the product of two sides, let's say A times B times the included angle sine C. But we know the area of a parallelogram is going to be twice the area of that one triangle. So if you multiply this by 2, the 2 is going to cross out, so it's simply going to be product of the lengths of the two sides times the sine of the included angle. So in this case, we can use this formula, or we can find the area of this triangle and then multiply it by 2, which is basically doing the same thing. So let us find the area of this triangle and then we can go from there. So guys, area of triangle ABD is going to be 1/2 of the product of the two sides, 5 times 7, times the sine of the included angle. So we have to use a calculator for that. So I'm going to use my calculator and see what we get for the value for this. 75 times sine, 35 times sine of 30. So we get 8.75. That is the area. Let us put some units here, guys. Let's say this is 7 centimeters, 5 centimeters. So it will be, area will be 6.75 centimeters squares. And then if I have to find the area of this whole parallelogram ABCD, that's going to be 2 times this 2 times 8.75, and that is going to be 17.5 centimeters square. So guys, it's up to you now whether you want to remember the formula that it's just the product of the lengths of the two sides times the sine of the included angle, or you want to break it into two congruent triangles and find the area of one of the triangles and multiply it by 2. So you're going to get the same answer whether you use directly this formula or you multiply the area of the triangle by 2. So 17.5 centimeters square is the area of this parallelogram. So guys, it does not only end with parallelograms. We may have figures like pentagons or hexagons where one has to find the area of those given figures. So guys, one can break those down into different triangles, and once you find if they are equivalent or if they are congruent triangles, then and especially with the regular polygons, we can create congruent triangles. And if we find the area of one of the triangles given the information, especially the two sides and the included angle, then we multiply by how many triangles we have and we can find the area of those polygons as well. So guys, keep those things in mind. Here I showed you some examples. I think I'm going to show you one more example for the area of the triangles, or more like an application of this concept of area of a triangle, and then we'll move into the cosine law. Okay, till then, take care. I will see you next time.